A third thing to discuss is the implication of the behavior of Git-fork and disk space. Some of you have been already involved in this discussion. The implications are that if you do a Git fork on Gitea, it basically creates a copy of the repository, even if this involves making it with hard links. Over time, it will start doing garbage collection and all kinds of other things, which means that you basically get almost a full copy of the original repository. Now, we have the ambition to go to a fork, fork branch, pull request, merge type of workflow, which means that everybody who wants to collaborate will end up having a repository of his or her own with one or multiple branches that they will send pull requests to us from. Now, that will work quite fine for, let's say 50, 60 people or so who do this on a regular basis. It becomes a problem if people just start forking Blender for the heck of it, trying to make a single line patch. These will consume considerable amounts of disk space. Now, this is something kind of unique to large projects such as Blender to tackle. Other projects with smaller repositories will likely not have this problem so much. We will have to see what it means for the documentation repositories because the moment they will move from SVN to Git, this will have the same type of effect. Now, the issue is that if you fork and it allocates all the disk space, maybe you don't have to fork. Maybe we would be able to say, look, we give you a branch in the main repository to do your changes on, and then we'll accept a pull request from there. For core developers, this might actually work quite well. But we have a lot of people floating around who are not core developers who we do want to have the ability to actually collaborate with us, and making a full fork and having them go, completely wild on that fork is really a comfortable situation to have. So just doing pull requests from local branches is not a strategy that we can accept. So an alternative that we found was the ability to leverage something called namespaces, support in Git for providing a namespace with which to create branches in. Essentially, you're saying, look, it's the same repository. All the objects in the repository are not cloned, duplicated, or anything, but they are. You create a namespace, and that namespace has a new main or master, has a new head pointer. It has for all the branches. It has the complete ability to act as if it's a real separate repository without having to actually duplicate any of the files. This is an interesting approach, which works fine on the command line, but can actually be leveraged also to have the behavior of a forge like Gitea to use a Git namespace method or mechanism to create a new fork of a repository, which is not actually a fork, but is actually just a namespace within which changes can be made as if it's a real fork. I've asked the people from Gitea, Matti specifically, to experimentally look into this, see if he could change the behavior of the default Git binary calls that they use to instead use Git namespaces to create forks. And technically, it works. Technically, it is completely feasible. The issue is one that other Forge owners, Forge operators, like I believe GitHub, has run into in the past already, which is that the moment you start doing that, you have the ability to actually operate on an object available in one of the namespaces, which is exactly the same object as in one of the original or in the original master repository. So essentially, if you're saying, look, this is the Blender repository, the main one where core developers have access to files that um, are, you know, protected for a reason because it's the main repository. We don't want to have everybody act on that and put commits in there without us noticing. But then you create a namespace, which is, usable for anybody who created that fork. That fork is then editable by whoever had permission to create this fork, which is a namespace. Now, all the files in there are basically objects, and these object pointers point towards the original objects here. Only the moment that you actually start altering them would you have logic in place that would create a local variant with an object that's only known here in this namespace and no longer really is known there, or at least nothing there refers to any of the changed objects here. What is a challenge, however, is that if you say, hey, I want to do an operation on one of the objects here, which are actually also objects that live on that side, you have to do very, very careful checking on permissions, because you could actually say, hey, I want to do something on this fork here on an object which is actually the same object as the one there. But it would check the permissions here and not the permissions there, which means that if you are not very, very careful, you open up a host of bugs and security vulnerabilities with regards to who can actually patch, commit, alter files that are present in a certain repository that has a namespace available to it that arbitrary people could edit files in. So looking at that mechanism, we concluded that technically it's feasible, it works, but we are not comfortable that the amount of time that it would need to do proper implementation of this for security reasons would actually be ready in time to have it available for a October deadline or an October ambition to switch over to Gitea. Plus, we also made a calculation which basically involves, what if we start doing the new forge without this type of mechanism in place? How long would it take realistically before disk space starts to be an issue? Now, disk space will definitely start to become an issue at some point, but not within the first year or so. Plus, there are some mitigation strategies which we could employ, which involve making the most important forks, or the first 200 forks or so, land on the disk that we start out with, which is most likely going to be fast SSD or NVMe storage. And then the moment we start having more and more forks from people who want to just do a single line patch every now and then, we move those forks, or we move the less used forks away from the fast storage and onto a set of cheaper, large spinning Rust disks, as I'd like to call them. So classical hard drives, let's say 2 times 12 terabyte, that would keep us comfortable for a longer period of time. Not ideal, but arguably quite an okay strategy. There are 2 more remarks to be made about this. First of all, The implementation of a namespace-based Git-fork mechanism is something that we could actually pick up or have Gitea pick up for us later, so that we could actually switch to that mechanism over time afterwards, after we've already successfully migrated. We could say, look, now we want this feature to mitigate the amount of disk space that we and other Gitea users will experience having to be used. And another thing is that the jury is still out whether or not we can do successful deduplication of blocks in the operating system, file system layer. That means we could enable a setting in ZFS, for example, to look at blocks that are similar on disk and say, look, you only have to keep one of these copies and make a pointer from the original to the two places where, or no, the other way around. Make two references from the places where it's being used to the original block, which you only keep once. This is a good strategy for a lot of applications. The issue here is that we expect that the behavior of Git will soon start to have cloned repositories start to diverge in very, very small but significant ways. Realistically, only a single bit flip anywhere in a block of data will result in it being a different block and require a separately allocated block on disk. So we are not quite sure how successful that strategy is, but given the cheapness of enabling it, will likely enable that for whatever amount of benefit it might supply. So that is currently the state of the Git-fork mechanism. We have decided to not implement Git namespaces idea, and we are going to look at the situation as it develops regarding disk space with some mitigation strategies that we already devised right from the start. That's point 3 of our schedule today.